Welcome to Paper Cam, Way of the Future. We've got paper, we've got crayons, and we're starting a new playlist. This is just going to be the introduction to it. And the idea is abstract algebra for kids. And it's not really going to be for kids. Maybe it's a little bit for kids, but mostly what I want to try to do is go through all the topics in a standard abstract algebra course and explain them, talk through them with a minimum of symbol pushing, a minimum of just manipulation of symbols. And what we're going to try to do is just explain things and draw them and doodle them and understand them. So, here we go. This is just going to be an introduction to the topic, and then we'll get into all the different subjects that you would have in such a course. So, when you study algebra in school, typically, middle school, high school, what that is it's a set of procedures that you'll use, like, I'm designing a floor plan or a lawn, and I need to have a fence around the lawn, and there's so much fencing, and I know this side, it's going to be 6 more than that side, and so you can kind of work through. It teaches you these procedures for manipulating variables in order to isolate them and find out what they are in relationship to some kind of problem that you've described using them. But that, I would say, is just the algebra of a specific kind of thing, the algebra of addition and multiplication and exponentiation and such things. When you talk about abstract algebra, what you're talking about is basically all possible algebras, like all the ways you could have sets of things and operate on them. And so we don't even need to talk about numbers anymore. Let's start actually getting into a little bit of it right now. So how about this? We got rock, right? We got paper, and we got scissors. And this is our set. It's a set of 3 things. And if I take 2 of them and I combine them, so let's say we say rock and paper, right? I want to combine these 2 things, and what do I get? I get the winner, right? The winner is paper. So you could talk about like the operation. Here's the set of things, and then the operation on 2 of them is determining the winner. Or you could also do determining the loser. And there's a set of rules here, and how do the rules work out? And what if we, is there an associative property of this? So like if I do rock, paper, and then I have scissors, doesn't matter if I do this first and then this. So some sets of things will obey this property and some will not, right? And in some things the order of them matters. And these are all the kinds of things you think about when you study abstract algebra. Let's look at another one. So let's say we're talking about colors, right? We got red, we got blue, we got yellow. And part of the reason I'm doing crayons for this playlist is this will discourage me from doing a lot of symbolic manipulation, because it's not going to be fun to do it with crayons. But it also will enable you to do nice little visuals like this. So when you mix colors, so let's say our set is colors. And suppose this is my set. And I mix red and purple. Red and blue. Spoiler alert, they make purple. But if this is my set, and my operation is combining them to form a new color, I'm noticing purple is not in this set, right? So I might say I better add purple to make this all work out. And while I'm at it, let's do the combinations of these, because we know red and yellow make orange, blah, blah, blah. So now, what if I combine these 2, yellow and green? Well, that's going to make a kind of a color that's a mix of these, kind of a yucky green, right? But that's not in this set. This set only has these. So this is interesting. It seems like I'm going to need infinite colors in order to make this thing work, the mixing of colors. Unless I cook up some rule to handle, like just giving myself this, and if I combine these two, then I have one that's already there, but maybe I set up a rule in such a way that I can just work with the ones I have presently. How about clocks, right? You've got a clock, well, 1, 2, 3, and so on, right? And let's say I tell you we have 6 hours plus 10 hours, right? And we're talking about a clock here. Oops. All right, so 6 hours would get me here to 6. Then if I had 10 more hours, 7, 8, 9, 10, I get here, right? It's 4 o'clock. So like 6 o'clock plus 10 more hours gets me to 4 o'clock. So that's a little strange, right? I add 16 plus 10 and I get 4. Is there some sort of set of rules which can handle this kind of math, which is not like our usual way of adding numbers? And we'll explore that in a lot of depth in abstract algebra. We look into that. What about closest relative, right? At a reunion or something. You pick two people, and then you just select who's their closest relative at this reunion. What kind of a set, what kind of an operation is that? Does it have, associative property, commutative properties? We'll go to what that even means. But what I'm getting at here is there's all sorts of structures for sets of things and operating on pairs of them. In abstract algebra, you will study and learn about the behaviors and the properties of all those different kinds of operations, sets associated with those operations, and there's permutations, there's all sorts of wild things, rings and groups and abelian groups. But we're going to try to see it all through the lens of things we can understand by writing with crayons. We're going to try to avoid a lot of writing down symbols. And so this is just the introduction to the topic, and I hope you'll come along for the ride.